So I figured this was a pretty important talk to give here because we have 27,000 trees that have been planted at MPG. There aren't that many that are surviving. It's a lot, really a lot of trees, and everybody should know why we plant them. I just wanted to include a brief little introduction about Lucas. I'm going to say a lot about we did this, we did that, but really Lucas is the one who runs a crew in the spring with Watershed Consulting and plugs all these trees in the ground between 5 to 10,000 every year. So want to give credit where credit is due. Okay, and one more thing. I want everybody to pay attention, so I'm going to bribe you. I have chocolate bars with little trees on them. My girlfriend is a 4th grade teacher, so she loves crafts, and I thought that I should include that. So I'll ask a few questions, and maybe at the end the best question gets one of these. Okay, so why do we plant so many trees at MPG? Well, we'd like the place to look really nice, and one of the earliest restoration proposals that Philip wrote for MPG, he wrote that he wants MPG to look less like the Great Plains and more like an estate. Something along those lines. And that reminds me of the Daly Mansion down by Hamilton. Maybe you've driven up that road. There's this beautiful hedge that runs up to the mansion, and maybe in 100 years it'll resemble that in some way. Also, we want to increase habitat, of course, because we're a conservation ranch. We want to establish wildlife corridors so critters can roam from the mountain down to the floodplain. We planted a lot in draws, and also we'd like to increase forage value of all these shrubs. Okay, so what makes a desirable shrub? At this site, it's dry, cold, hot, windy. These plants need to be able to tolerate a really awful environment at times. So we can't place aspens right along the road, they will die. But junipers do very well. We've planted lots. I would say that over 50% of the shrubs are junipers that are still alive. Next, it needs to taste good. So here's the first question. Really quickly, who can ID this? You got it, Becca. You're in the back, so I'll give this to you later. Leave it to the botanist to jump in there. Mountain mahogany is not commonly found at MPG. It's not found at all, actually. It grows in the southern bitterroots, mostly on the sapphire side and Sleeping Child, and in those areas, the West Fork of the bitterroot. It's great for forage because it is a nitrogen-fixing shrub. There's a lot of protein in the leaves relative to other plants. Other things that we want with shrubs are apples, fruits, delicious leaves. We've planted orchards. And next, we also want plants that provide other benefits to the ecosystem. Here is rabbitbrush. These things flower all the way into the fall. Pretty soon we'll just be planting these for Mary Rose, I think. We'll see. So like juniper and rabbitbrush, they can provide habitat and cover for a lot of animals. We planted a lot of plants on south-facing slopes. Those can help stabilize the soils. And lastly, you've probably noticed the weed problem that Dan has just taken care of recently and continues to do. And trees can help compete with the weeds. This map right here shows all the areas that we've planted. Red is areas with hedges or just areas of plants. And so where should we plant all of these? The first place is along roads. These are areas that could be beautified. It'll make the ranch look nicer if we do that. And in some of these lower areas along roads, the roads are close to egg fields. So if these shrubs get established, these shrubs can provide cover for birds and animals that want to go into the egg fields. And also, hopefully, these could prevent big snowdrifts in the future, but we'll see. I wouldn't be surprised if the snowdrifts just take out our trees. Springs are another great place to plant trees. We have springs all over the place. For instance, in this area, we have spring here, so we've planted this entire area. There's lots of water. Wherever there's water, that's a good spot to plant. Which leads into the next point. If we have a well or a stock tank, a spring, we can harness that water and transport it over long distances through drip irrigation systems. So as long as we have water available by some means, that's a great place to plant. Also, degraded sites. What comes to mind first is the wetland. This area used to be a sporting clay range. there was a lot of sediment that was removed, and that's now a wetland that is being revegetated. And lastly, historical vegetated areas, and those include some of the northern draws. Up here, aerial photography shows that these had quite a lot of vegetative cover, and they have some now, but we're increasing that. So we've monitored all these plantings since 2010, and we've done a lot more monitoring in the past 2 to 3 years. We'll go to all these trees in the spring and the fall and just see whether they're alive or dead, and we'll also do measurements to see how much they grew. So here's our report card. At first, it looks awful. In 2010, we planted almost 11,000 trees. Only about 4,000 survived to the fall, giving us a 30% alive rate. This is pretty bad. Part of the reason for that is trees were planted in areas where there were a lot of weeds. This is a perfect example. This is along the road going towards the top house, just above Woodchuck Creek. 11,000 trees. We found that they all needed to be watered. We had a watering crew going for 4 or 5 days a week, and that just wasn't enough to keep everything alive. So we learned a lot from that. The next year we planted fewer trees, and we put them in locations that had better aspects, more water. We devoted more resources to keeping them watered, and the overall survival rate jumped to 51%. And really important with this graph is 11,000 trees were planted here, about 7,000 were planted here, so that gives us a total planting number of almost 18,000. So this column represents all the trees that have ever been planted at MPG. And because we had such a bad survival rate that first year, that kind of masks the survival rate we've had in the past few years. And because there's so many plants, 27,000, it's hard to adjust this alive percentage unless we plant a lot more. So my next question is, in these past 2 years, we've had a much better survival rate, just considering plants that grew from the spring to the fall. Can anybody guess what that is? Come on, just throw out numbers. 70%, higher.
80.
That's it?
97.
Not that good, that's too optimistic. Close.
90.
Lower than 89?
87, 86.
I'm going to give it to you. 85, you got it. Thank you. Thank you, Bo. 85%. So 38% the first year, and now 85%. This is awesome. We're doing such a better job. And that says that right here. If we only consider survival rates from year to year, the survival rate jumps to 85%. We're doing much, much better. And part of that is because of drip irrigation. This is Colin Kornberg coming back from his first trip to the irrigation store. And the best part of this photo is you can't see what's in the cab. It's more drip equipment. And, and none of us had done any drip irrigation before. And to be honest, I was, I guess, a little bit nervous that this might not go well because we had ordered about 5 miles worth of drip irrigation. But it's really not that complicated. Water flows downhill, and as long as you don't have leaks, you can just make these lines that go through the trees. Then off of these lines, you have smaller lines that go to drip emitters, such as this, and you irrigate trees right at their root. This is a very easy and efficient and effective method. We just turn these things on. We can do, on a single system, hundreds of trees just by flipping a switch. And the water drips down very deep as compared to hand watering, which we had been doing before, which is very time consuming. Something else very important given the circumstances of lately. We had overland flow in Partridge Alley. We had 21 CFS, cubic feet per second of water coming down this draw. And look at how these drip irrigation setups withstood the flow, and they actually prevented erosion, all this matter collected behind them. So that really attests to the strength of these systems and that they're not that brittle. They're going to be there for quite a while. So we've done a lot of different experiments to determine how we can make plants grow better, and I'm going to start throwing out some of these figures. So drip versus hand watering. Does it grow trees faster? We know that it's way more efficient. We don't need to hire as many people to water trees. And yes, drip irrigation does work. We have a height increase. This is data from 2012. This shows that drip irrigated trees, this green bar for juniper, makes trees grow about a third faster for juniper. And about the same goes for ponderosa. The star indicates a significant difference at the 0.05 level. So that's good news. And so we started taking all that information into the future plantings. This is in sheep camp. In 2012, we knew that we needed to do things a little bit better, plant things in better soil. We need to have drip irrigation. I want to point out this rabbit brush in 2012. This was planted in the spring 2012. I took this photo in the fall of 2012, and here it is, fall 2013. It's giant. I've never seen a rabbit brush this big anywhere. These are plants that love dry areas, and all of a sudden we gave it some water and it's living in a near marsh. Not really, but there's a lot of water. And golden currant's thriving. Juniper grows slowly, but it hasn't died, so that's good. And I mean that seriously. We've planted a lot of junipers and ponderosas that are really big, and we've had very little success with them. And back to mountain mahogany. This is a pretty big mountain mahogany. It was planted in 2012, and this red line represents the mean height of all mountain mahoganies that were planted that year. This next line represents how much they grew over that 1 year. So very little. Wrong way. And then this upper one shows how tall this plant is relative to the mean height of all of them the previous year. So what I hope this means is that once these things get established in their first, second year, they're going to start putting on tremendous above ground biomass. Perhaps this plant the first year was just putting biomass into the roots. Okay, so this is a comparison of growth rates between 2012 and 2013 for plants that we planted in middle drought. If you're at what is the rock pile, Jeff's going to take that out, but if you look at Lower Tongue Creek and then Lower Sheep Camp, in between those draws, I call middle draw. We monitored those trees from 2012, 2013. So this is showing height increases for all these different species. These open bars are 2012, gray bars 2013. These are box plots, so for instance, Elderberry, this bar right here represents the median. This is the 25th quartile, 75th, 95% confidence interval. So these are nice because it shows the distribution of all the data. There are a few things I want to point out about these growth characteristics. So if you look at buffalo berry, which is something that we don't find at MPG besides what we've planted, you find it east of the divide. It grew a little bit last year. It's growing a lot now vertically. That's great. Those are doing well. Elderberry, it looks like there's this huge decrease in height, but that's really not what's going on. When these things are planted, they're about 2 leaves like this, and they're about that high. So if you take a 4-inch plant and it grows up to 12 inches, all of a sudden it's, what is that, a 200% height increase? So once it's a little bit higher or taller and starts growing more outward, it appears that there's less of a height increase. Golden currant, this is something I'm really excited about. It's similar to the gooseberry that we see around. It has berries now. Some of these are producing berries and they're delicious, but I want to warn all of you not to eat them. They're for the birds and for the animals. So although I said they're delicious, don't believe me. They're growing great. So in the next few years, we should be seeing a lot more berries. And then the one that we're all excited about is mountain mahogany. Again, like I showed before, not a big growth increase the first year, tremendous growth the second year, and there's a very huge range of the growth. So in 2013, we decided it was time to do something about these south-facing slopes that are eroding away. These are just awful sites. You can see this evidence of erosion, and there are some bitterbrush hanging on. They must have very deep roots that keep them rooted in there. What's interesting is on the north-facing sides of the draws, there's really nice soil. So I think there's just more water, more weathering over time in this area. Over here, less water because it's very dry and probably eroded from cattle and everything else walking over them. So Watershed Consulting, Lucas's crew, came out last year and put in these erosion control bars. Now these help with the erosion because as the material falls from the higher areas, it'll lose slope, collect here. So as water is coming down here in big rainfall events, it'll slow down velocity and hopefully infiltrate here. And overall, it should decrease erosion. They planted mostly juniper, mountain mahogany, and bitterbrush in these sites. Very drought tolerant species. So we have some figures here. Does irrigation help for these trees? And first of all, are these trees and shrubs really growing that much? The percent survival is on the y-axis. Again, bitterbrush, juniper, mountain mahogany. And this is sheep camp. Everything is on drip irrigation. We have a stock tank system here that we feed to Middle Draw, and in Tongue Creek we have a well. In sheep camp, bitterbrush survival rates 50 to 70%. Water helped a bit. Didn't do any statistics on this. We'd have to group them all together. Junipers, we didn't have a single juniper die in sheep camp. Junipers lose their leaf pigment really slowly, so perhaps some died and we just weren't measuring it in the fall, or they just are all kicking butt. Okay, next, mountain mahogany. These things need to be watered, and even when they do receive water, their survival rate isn't extremely high. This is around 60%. Middle Draw, it's important to note this asterisk. There is no not irrigated treatment. It's a small draw, and there weren't enough trees for a good sample size for the not irrigated treatment. So we irrigated all of them, and it wasn't so good for bitterbrush. Quite a few died. That could be an irrigation issue. We had a few problems right off the bat with our drip irrigation systems going to Middle Draw. But otherwise, kind of similar. Juniper, 80%, mountain mahogany, about 40%. In Tongue Creek, again, low bitterbrush survival rate. Water didn't seem to have too much an effect in those areas. It'll be interesting to go back to those shrubs this upcoming year and then see what really went on, because it's possible these shrubs were in the process of dying and we didn't catch them. So I think, yeah, this next year's data set is really going to tell us what occurred. And how fast did the plants grow? That last one was survivorship. This is growth. Bitterbrush, not so great. Juniper didn't grow very much, about 25%. Mountain mahogany, pretty good around here, 50%. Again, that's Tongue Creek where we had the high or moderate survivorship. And right around here is about similar to juniper. So not fantastic. Hopefully next year things shape up. But what's really, really interesting, I think, is if you're taking the road up to the top house, there's this bend right here in the road when you start going uphill. If you go down the draw and come to this hillside right here in Woodchuck, Lucas's crew planted a lot of mountain mahogany, bitterbrush, juniper, and rabbitbrush. Survival rate above 80% for everything, and everything was irrigated. This site has good soil, probably not as hot for a reason that Dan brought up with me a while ago. So the elevation here is about 200 feet lower than the elevation right here, and the sun's coming from down here, so this area might stay shaded longer into the day. Here's a picture of a bitterbrush in this area. So they're branching out, they're doing fantastic. And here's the height increases. Bitterbrush did great, about 150% or more height increase. And the height increase measures to here. It doesn't measure all the branching. And something else I want to point out is rabbitbrush. These things get huge when they're drip irrigated, as we saw earlier, and there's a big range in how big they're getting. So just very briefly, this is a typical planting scheme for the Northern Draw, so you kind of all get an idea of what we're doing up there. And this reiterates what I'd gone over. Everything in the yellow is the south-facing slope, so mostly bitterbrush, mountain mahogany, juniper, and rabbitbrush. Everything in the green, better soils, and we plant all those trees that we had previously, that I had just brought up, plus others like buffalo berry and currants and other fruit bushes. And lastly, I haven't brought up, is we've planted orchards in blue. These are apples, plums, nuts, as well as choke cherry, just native fruits, things that should provide some real great forage. There are a few other little things I wanted to bring up that are kind of tangent to what I'd previously discussed. We want to plant trees in higher areas and not irrigate them. Irrigation is a big time constraint, especially when we have to drive up to Mount Baldy to do it. This is the wire spool junction right here. So this spot in blue is the area we planted just before the wire spool. We planted elderberry, limber pine, maple, serviceberry, plants that you would expect to be up there. And we had pretty good survival rate, especially for limber pine, because we had planted them previously, and I can't remember what the survival rate was. I should have looked it up, but it was like 3%. It was like one tree survived out of all the trees we planted. Elderberry, every single one lived. Maple, about 60%. Serviceberry, 90%. These are very encouraging. We should be able to go up there and poke trees into the ground all over the place and just leave them alone and let them grow. This site is higher elevation, has a northwest aspect, so it's not going to receive sun like the rest of the ranch that faces the south and west. It'll hold snow later into the season. And also we have a rain gauge pretty close to here that showed that this area gets a little bit more precipitation, which could be true or not. It could come down to a wind effect possibly. Maybe there's more wind down low, less wind up high, so precipitation was maybe the same, but we didn't pick it up. Another thing, down in these lowland irrigation areas, we want to know whether we can take the irrigation off the trees and let them survive. So we did that this year with plants along the entrance hedge. That's the hedge that you see as you're driving into the ranch, take a left towards the orchard house. It was irrigated last year with drip irrigation and the previous year. So 2012, 2013. In 2013, we took them off drip irrigation, and we had a control group that was irrigated. And irrigation made a difference for junipers, but not ponderosas on the entrance hedge. The star, again, is the significant difference. That was really interesting. I figured that ponderosas would need water more than junipers. And Partridge Hill, this is the hill that's above the turnaround. Same result. Junipers, they grow better with water. Ponderosas, not so much this year. Maybe in the future, like next year if we monitor this, we'll see a difference. Okay, growth rate comparisons. Do older trees grow faster? If we take a single tree and measure its growth rate in 2012, if we measure the growth rate again in 2013, does the 2013 growth rate exceed the growth rate of 2012? And we found that in junipers, it doesn't. The height increase remains about the same. But I want to point out that junipers, they grow out quite a lot laterally, and although they could be putting on more biomass, we wouldn't pick that up with a height measure. Ponderosas, they grow laterally as well, but a lot of their growth is vertical, and we did pick up a trend there. The older trees are growing faster, so hopefully with ponderosas in the future, we'll just see them grow and grow and grow more rapidly. And my last random slide is, does fertilizer work? And I should have put a question before this and asked, does fertilizer work? And see if anybody got it right. It does. This is the control group of fertilizer. We fertilized junipers. This is the control group of junipers, grew about 40%. And we added organic fertilizer and conventional fertilizer and found about at least twice the growth in the fertilized treatments. Organic fertilizer wasn't any better than conventional. There's a lot of overlap between these error bars, which, by the way, have always been standard error. So, in conclusion, we're getting good at keeping plants alive. Again, 85% survival rate. It's fantastic considering where we're at. Drip irrigation works. Where we have water, we want to use it. Put it to good use, get these trees succeeding. Fertilizer works. We should get Katie busy with a bucket of fertilizer so she can make all these trees huge. And again, location matters. If we put things on the northern aspect with good soil, with water, we can expect good things. And acknowledgements, the watering crew who has done almost all of the tree measurements and keeping things closed, as well as the field crew. Katie, Colin, Alex, Rebecca, Sarah, thank you. And